Okay, we're gonna do a bunch of kind of house cleaning. So there are some different problems and different lessons that we didn't finish on notes. We're gonna check over this homework that's due today, and then also a homework that was from last week, the day that I was gone. I just kind of want to make sure that we've hit some different things that we've sort of not kind of wrapped up. All right, so let's start with checking homework 25. Any questions on that group of problems? Jeff? Which problem? For number 3, how do I get the tangent of L? Okay, so I redrew this triangle over here so that I would be able to write on it without having the other stuff there. So you were given the lengths were 12, 12 root 3, and 24. So I went ahead and simplified those down, and that's a 1, 2 root 3. That's actually a 30, 60, 90 triangle. So I simplified it there, and then the tangent of L is the opposite over the adjacent, which is 1 over square root of 3, and then I rationalized it, root 3 over 3. Okay, and you don't have to simplify back there. Remember, this is kind of what we did yesterday also. On this one, I showed you the, finding the ratios and simplifying, and then I went ahead and simplified them and did the simplified form over here. So if you start the problem by looking at the numbers you've got on the sides and simplify those down, then you won't have to do the simplifying the fractions every time. Okay, but special right triangles that I can ask you radicals with are going to be 30, 60, 90s and 45, 45, 90s. Okay, if I ask you for a 30, 60, 90 or 45, 45, 90, the ratios, those are going to have square roots of 3s and square roots of 2s in them. Anything else on 1 through 3? Jake? Which one? This one? Oops. This one? Okay. So I just simply took that tangent and flipped it over. So remember that those are reciprocals. So rather than taking this and flipping it over and then having to rationalize, I just flipped that over. You can also look and say tangent of M would be the opposite over the adjacent. So it's square root of 3 over 1. It's in relation to M, that's your opposite and that's your adjacent. Anything else? Okay. I emailed you guys about number 6 here. That is not going to be on the test, and I don't want to confuse you by talking about that right now. We have tons of stuff on this test, and so don't look at number 6. If you knew how to do that, that's awesome. We're going to continue with trig after the test, but it's just one more thing that you don't have to know how to do for right now. So these problems, this one, you multiply 8 on both sides to get the denominator to cancel out over here. And then on this one, you've got the variable in the denominator, so you want to multiply by x on both sides and then divide over sine of 18. I don't think that I had time to tell you guys this yesterday. Some classes we did talk about it. But another option, another option for solving that equation. So same equation, sine of 18 degrees is 6 over x. If you prefer to just turn that into a proportion, okay, just throw it over 1 and then you can cross multiply to solve. So if you'd rather not have to think about, okay, I'm going to multiply by x on both sides here, If you just want to turn it into a proportion, then when you cross multiply, you're going to get sine of 18 multiplied by x equals 6. And that's the same thing that you have here before you multiply both sides by x. So if that makes more sense to you, you can do that whether you have the variable on the top or on the bottom. You can also do it on that one and cross multiply. Okay, so if putting that into a proportion form is simpler, then just do that. You know, instead of thinking about getting rid of the fraction, it's going to give you the same answer in the end. Like here, you know, we'd have 6 divided by sine of 18. So especially on the one where the variable's in the denominator, sometimes we get a little confused on how to solve that. Okay. And then the 45, 45, 90s we haven't done for a while, so you guys seem to be really good with that. When we first went over, it's just, you know, been a minute since we've done these problems. So remember that in a 30, 60, 90, this is called a reference triangle. So in a 30, 60, 90, your ratio of sides is 1 root 3 on the long leg and then 2 on the hypotenuse. Okay, and then in a 45, 45, 90, you've got 1, 1, and what? 1, 1, and Paul? Square root of 2. So remember, both of them have square roots in them. The one that has the 30-degree angle is the one that has the root 3. That's one way to remember that. Okay, or the one that has 2 congruent sides is the one that has the 2 in the radical. Just make sure that you don't mess up which one is root 2 and which one is root 3, because that's always super tragic. That throws off so many problems if you make that mistake. Okay, I'll stop moving around now. Take a look at those, 1 through 10. Now, hopefully you did not do trig on these problems. That means hopefully you did not do sine, cosine, and tangent. This is always a situation here. Whenever you have 45s, 30s, and 60s in your triangles, you will not do trigonometry in general, okay? See how I asked you for, in the directions here, I said express your answers exact and simplified radical form. That means do not do trigonometry, because when you start touching your calculator, you're going to be getting decimals. And I don't want decimals. I want radical 2s and radical 3s, okay? So whenever it's a 45, 30, or 60, you got to watch out for special right triangles. When I say no trig, that means no SOHCAHTOA, no sine, cosine, tangent. Paul, what was your question? 20, whatever, 22.5 or 2. That's fine. I mean, we talked about that before, and I said I usually probably leave it in a fraction form, but you can, as long as it divides evenly. You never want to round on those. So if you had like something over 3, you can do a repeating decimal, but I would just do leave it as a fraction. Questions on 1 through 10? Jack? Yeah, you've got the short leg. So to get from the short leg to the long leg, you're going from here to here. You're multiplying by square root of 3. And then to get to the hypotenuse, you're multiplying the short leg by 2. Now, you're trying to get a bigger number, you're multiplying by root 3. If you're trying to go from the long leg to the short leg, you would be dividing by root 3. You're trying to get a smaller number. So typically the 30, 60, 90s that are simplest are the ones where I give you the short leg, because then you're multiplying rather than having to divide. So like this one was nice and simple. This one, you know, you're just multiplying by root 3. When I give you the hypotenuse, that's not a nice number, or I give you the long leg, that's not a nice number. then, those are usually going to require more work. Okay, but again, I'm going to emphasize here, do not do this. If I ask you to find y, and you do, let's see, the tangent of 30 degrees is 9 over y. Okay, you're not going to get a 9√3 answer. You're going to get a decimal answer. Okay, when you type in 9 divided by tangent 30, put on my calculator up here. When you do 9 divided by tangent 30, you're going to get that. Okay, I do not want decimals on these problems. Whenever there's a special right triangle, make sure a 30, 60, or 45-degree angle, make sure that you're not using trig. You do not want trigonometry. Now, I'm saying this several times because every time that we take a quiz or a test where special right triangles and trig is mixed together, there's always a handful of students that do trig on like everything because that's the most recent thing that we've done. Okay, make sure you don't do that because then you're not getting radicals, you're getting decimals. Okay, here's the bottom of that one. And again, when it says exact length, anytime it says exact, exact and simplified, simplified radical form, exact and simplified radicals, anytime it says exact, that means you should not be rounding. Okay, exact means radicals and fractions. So that said exact, this also said exact down here. Did any of you do trig on 11, 12, or 13? Be honest and tell me. Did anybody do trig on 11, 12, or 13? Really? Nobody did? Not a single one of you? Okay, that's good. But again, just make sure you understand that when I say exact, and I'm talking about special rate triangles, you've got to make sure you're giving me radicals, not decimals. This one I said to round. Okay, so that one you can either do, there's a lot of ways you can do this one. I just did the 45, 45, 90, a 6√2, and then I just typed that on my calculator to get 8.49. What's another way you can get the hypotenuse length for number 14? What's another option for 14? Person? Sure. You can do the Pythagorean theorem and then at the end just do the square root of, what is that, 72? Just type in your calculator and get the decimal. You don't even have to break down the radical before you type in your calculator. You can just do the square root of 72, 8.49. Okay. You could actually also do trig on this one because I told you could round. You could do, like, for example, the sine of 45. 45 degrees here, the sine is the opposite over the hypotenuse would be your x. Okay, so if you did the sine of 45 degrees is equal to the opposite, which is 6 over the hypotenuse, which is x, you would be doing 6 divided by sine of 45, 8.49. Okay, the reason you're allowed to do trig on this one is because I told you were allowed to round. Okay, the rounding ones usually give you more options. When it says exact and simplified, that means either, so like this one, if I wanted an exact value here, you could either do the 45, 45, 90, just give me 6√2, or you could do the Pythagorean theorem and simplify it down to 6√2, but you wouldn't do the rounding at the end, and you couldn't do trig if I wanted an exact value. Oh, that's the end. Okay, let's go back to homework 22. You turned in last Wednesday when I was not here. And I showed you this answer key, I think. Some classes I showed it to them like at the very end, the 5 minutes when I was cleaning. So some got checked and some didn't get checked, and we did not have a chance to talk about questions and whatever, okay? This is number 22. It was on lesson 7.5. So I wanna make sure that we're set on the problem from 7.5 because that will be on this test, and we really didn't do the review part that I typically would have done the following day since I wasn't here. Okay. So one of the theorems in 7.5 was the side splitter. remember that if you have parallel segments here, then this ratio can be compared to this ratio. The segments on the sides are proportional. Okay, the sides are parallel here. The non-parallel sides are cut into proportional segments. So I did 12x over x plus 3 is 6 over 4. If you wanted to do similar triangles, that would still work. Okay, it's okay if you wanted to do, for example, like 4 over 10 and x plus 3 over, what is that? 15, I think, right? When you add those together. You could still do this is to that as this is to that. Okay, so you can still use similar triangles if you want. You just don't have to when you're comparing the sides that are being cut by the parallels. Same thing on the one here. You could do 12 over 15 equals 2x minus 3 over 3x minus 15. Usually it's simpler to use the side splitter theorem and get the ratios like this, but it doesn't have to be. Sometimes it might be easier to do the other thing. Okay, now this theorem down here, whenever you have an angle bisector, the angle bisector cuts the side of the triangle into segments that are proportional to the sides. So if this is a 1 to 5 ratio, then this needs to be a 1 to 5 ratio. So 20 is to 16 as 4 is to x, or you can go 20 is to 4 as 16 is to x. Okay, but that one, I don't care if you leave it as a improper fraction, decimal, or mixed number, because those are all exactly the same. But again, do not round. The only time you should be rounding is when the problem says round to the nearest whatever. Otherwise, I'm going to want fractions and radicals and exact decimals. Okay, if I say exact and simplified, writing 3.2 is okay because that's an exact value. Okay, and then we have 2 more problems like that one that we just talked about. So we got angle bisector ones on those. So those are similar kinds of problems. Now this one right here, you were not given the little pieces. So you have to make sure you think about the fact that if this is 18 and this is x, that's going to force this one to be 18 minus x. Okay, sometimes that's one that trips people up a little bit. And then again, over here, make sure that you're comparing pieces that are in the same spots. So we have parallel, that means we can cut the segments proportionally. So I did 32 to 12 and 40 to x. Tell me a different proportion that also would have worked. Let me set up differently. I did the part with the whole on mine. Maya? Okay, 32 over 40 is 12 over x. So that's comparing numerators and comparing denominators. That would be equivalent. I wouldn't have done it this way, but you could do, for example, if you wanted to compare 12 and 20, what would the other side of your equation be? So x over 40 minus x. Just make sure you're comparing pieces that are in the same spots so that makes sense. Okay, so pay attention to whether you're given little pieces or whether you're given the whole entire segment length. Okay, now I put some of these on the homework for tonight. I want to make sure that you are understanding what's going on with these proportions. So because we have parallel lines here, it cuts those segments proportionally. Okay, so that means that something like CD to IJ is going to be the same thing as AC to AI. So you're kind of picking pieces that are in the same spots. Okay, like for this one, BC over HI. BC over HI equals what over IJ? Well, IJ is here, So it should be CD. Okay, when you fill in the proportions here, you should be picking things that are in the same positions as what you're comparing it to. So FG to EF, that's FG to EF, is equal to CD, and that would be BC. Okay, how about, let me find one that, I don't know if I did. Yeah, so like this one, number 4, GD to AD, GD to AD is equal to JG. JG is over here, and then you need to use the entire side there. So that's actually kind of using the fact that you have a triangle here that has an angle bisector. So it's cutting the segment here compared to that in the same ratio as the segment here to that. But basically, you're just always kind of looking for things in the same spots. Questions on 1 through 6, that little group right there. Okay, how about the these? So remember that we talked about how you can just divide the radicals there. I was sort of showing you the steps and kind of why that makes sense, but in my head, I would just go straight to, for this one, I would go straight to 1 over square root of 9 and make it 1/3. Because you're thinking kind of like square root of 2, and then this is square root of 2, square root of 9. So it becomes 1 over root 9. You're just dividing out the root 2. So I did a few more steps there than you really need to have, but just kind of showing you how that works. Okay. Take a minute and look at those word problems. So don't forget that you're going to have geometric mean stuff on this test. So when you see those right triangles with an altitude of the hypotenuse, remember that that can be this, that can be this, and then you always have Pythagorean theorem to use. Area of a rectangle is length times width. So once you figure X and Y, you can just multiply them together. Questions on these 3? Okay. By the way, reminder that you should not have fractions underneath square roots. You shouldn't have radicals denominator. You should not have, I didn't cross this one out, but should be, you should not have decimals underneath radicals. Okay, none of those are simplified. So make sure you're not leaving radicals unsimplified, because that's gonna ding you a little bit, you know, here and there. Jeff. FC and FC plus FD, and then FD. Okay, the reason that I would put, I don't think it's a problem to put FD there, but the reason that I think it's better to put DD here is because it's going F to E, so it should be going D to B. I don't really care about that order because that's not really being used to compare another like corresponding segment, but I do think that one should be DB. So again, remember when you're comparing the parallel segments, you need to be using similar triangles. So if I said BD compared to EF, tell me a correct way to finish that off. BD compared to EF. What is the correct way to finish that proportion? I haven't talked to yet today? Ainsley? Did you say CB? Okay, so BD is to EF, oops, to EF, and CE is to CB. Yeah, yeah, she really meant, just kidding, right? She really meant that. Okay, so you have the right segments, you just gotta make sure they're in the correct order. Okay, why is it wrong if you said C, why is it wrong if you said right here, BE and CE? Why is that wrong? Because sometimes you're allowed to use the little pieces, sometimes you're not. Why on this one do you have to use the whole entire CB segment? So,
because BB is the whole entire side.
Yes, every time that you use the parallel segments in a proportion, you have to be using similar triangles. So that means you have to be using whole sides. Okay, every time that your proportion uses the parallel segments, you have to either say this to that or this to that. Okay, you don't want to be using the little segments unless you're comparing the sides. If you're comparing the two sides, you can do this to this and this to this. But if you're going to involve the parallel ones, you're no longer allowed to use those. Okay, you're going to use whole side lengths. Okay, let me zoom back out here. Any other questions on, yeah, let's just look at those. Any other questions on these two in the middle here? And I did post this answer key in Schoology. I think I may have said that to you, but again, I think we were at the end of class and it's kind of rushed. But this answer key is posted in the answer key folder if you want to go and pull it up and look at it again later. Okay, and then the last two here. So again, on one like this, because you're comparing the segments that we're trying to see if they're parallel, but the segments that would be parallel, when you do 10 to 20, that's a 1-to-2 ratio. This should be a 1-to-2 ratio, which it's not. Okay. The scale factor of the two triangles would be 1-to-2, but this is not 1-to-2. When you're simplifying radicals, if you end up with something like, even along the way as you're simplifying, if you end up with radicals that are the same, you can cancel those out. Then you don't have to rationalize on one like this because you can divide out the root 2 on the top and the bottom. Okay. Any other questions on anything on this homework? There's sort of a lot packed into this assignment. I had used this in the past to actually be a review for a quiz, including 7.5. We didn't take a quiz on 7.5, so I just used that as the homework, but that does have really good review problems for lesson 7.5. Okay, let's go back to, let me go look at the lesson 7.5 that we did. Tell me, go ahead and open up lesson 7.5 and tell me if we finished the second page of these notes. Some classes I did and some classes I did not. Did we get through all of those examples and problems? We're good with that? Okay, good. All right, and then the next thing, let's go back to Schoology. In today's folder, I put in a couple of practice problems there. So if you look here, it says opening questions 7.4 and 7.5. I'm going to give you a few minutes to try those problems, and then we'll talk about them. Questions on number 1? Give me a different proportion that we could have used here. Give me a different proportion to find y. I did y to 15 and then 14 to 12. Tell me a different way you could set that up. What if you did like Lucy? 8 over 10. 8 over 10? Oh, you used the 8, you guys. I was like, wait, where's 8? Okay, so you used x that you already found. Okay, that's good. So since x is 8, if you did 8 over 10 is 12 over 15, right? Oh, you used, okay. That was actually what I was, that's actually what I was going for. 14 and y. So if you compare 14 and y, if you're comparing the parallel segments, oops, if you're comparing the parallel segments, you would want to say 14 is to y as, and you said 8 is to 10. You could also say 14 is to y on the other side of the picture. 14 is to y as 12 is to 15. So whether you put 12 over 15 or whether you put 8 over 10, that should work out to be the same. Jake?
Why would it be 8 equals
2 over 8 is y over 14. Okay. Every time that you're comparing the parallel segments, okay, every single time that you use the parallel segments, you have to think about similar triangles. 2 is not a side of a triangle. When you use 2 in your proportion, if you've got a proportion that has the 2 in it, then that means you've got to be stuck on the sides here. You can't use the y and the 14. So if you use 2, you could say 2 is to 8 as 3 is to 12. Or you could say 2 is to 3 as, that's what I just said, isn't it? You could say 2 is to 8 as 3 is to 12. Or you could do the whole thing and you could do 2 to 10 and 3 to 15. But every time that you use the parallel segments, if your proportion involves the y and the 14, you have to use side of a triangle to side of a triangle or side of a triangle to side of a triangle. You're never going to use those little parts that are not sides. Sometimes the way that I set mine up was y over 15. Sometimes students find it easier to look at it like y and 15 are sides of the big triangle. And then in the small triangle, the corresponding sides would be 14 and 12. So rather than kind of jumping back and forth between the two triangles, you sort of look at the triangles and their corresponding sides. Sometimes it's easier to say, okay, the big triangle, I've got y and 15, and then the small triangle, I've got 14 and 12. Okay, but every time you use the parallel segments, you're going to be having the whole sides of the triangles. Josh, this was in today's folder. Do you know what we're doing? Did you see that? Okay. I'm sorry. Okay, good. Okay, how about, so that's probably going to catch you here as well. So Jake, see if you, I'm not picking on Jake, I'm sure that he's not the only one that did that on the first one. See if on these problems, if you had an issue with getting the right parts there. Let me know if you think I made a mistake. I just worked these out and I didn't double check myself. So if you think there's something wrong, we'll talk about it. Emily. Uh-huh. Oh yeah, you could have. I was trying to see if I got all of those. So I did AC to AB and then to the little pieces here. But yes, you absolutely could do AC to AB. And then Emily, what did you have? AE over AD. Yes, that would work as well. So kind of a totally different idea there, but that would totally be fine. So this one, oops. That one is using the similar triangles instead of the little pieces on the sides. Jake? This one? Okay, so DE compared to BC. So DE is, again, the parallel, and BC is the parallel. That means that we need to be comparing the two triangles. The bottom of the big triangle compared to the bottom of the smaller triangle has to equal a side in the big triangle over a side in the small triangle. Well, if the side in the small triangle is BA, then the corresponding side in the big triangle is DA. Okay, so we're doing bottom of the big to bottom of the small, side of the big to side of the small. Sometimes after you fill in what you think it is, if you go back and look at the picture again, it'll kind of like make you feel good, like, yeah, that makes sense, or wait, I wrote down something different than what I meant to, right? Kind of double check yourself on those. These problems are intended to help you catch if you're setting up the proportions incorrectly. Again, every time that you are involving BC or DE, which is what's happening on this one as well. Okay, if you compare AC to BC, then it's got to go AE to DE. You're not going to be using that whenever you're using the parallel segments. You will not be using either of those parts. Are you good with that one? Okay. So the stuff in 7.4 and, well, you had 7.4. The stuff in 7.5 is not that difficult. It's just that there's little things like that that sometimes you don't get the first time around. And since this is a test, not a quiz, you haven't had a quiz over 7.5. So I would just want to make sure that you're comfortable with the 7.5 stuff since it's been a while and because it's on the test without having had a quiz on it at this point. How are we with 3 and 4? You might have a different proportion, but you should have still gotten the same answer. Lucy. Okay, so did you not get 3? Okay, so you said 4 over 11. Let me switch colors here. 4 over 11 equals 2x plus 2 over 7x plus 1. Did I write down what you said? Now, that should be the same as mine because when you cross multiply, you're multiplying 4 by 7x plus 1, and you're multiplying 11 by 2x plus 2. So these are equivalent proportions. Tell me what you got next. Yeah, there we go. So the common mistakes on these would be simplifying incorrectly, just doing like when you're doing that, just a simple multiplication mistake, or forgetting to distribute also sometimes happens on those. Okay, so it's fine to say that because again, you're using the parallel segments. You're saying the bottom of the little triangle to the bottom of the big triangle is equal to a side of the little triangle to a side of the big triangle. You're not using the 5x minus 1. You're using the 5x minus 1 combined with the 2x plus 2. So 5x plus 1 should not be in your proportion anywhere. Okay, any other questions on these problems? I'm hoping that's helpful and that we'll get that straightened out with the ones that involve the parallel segments there. Okay, and then lastly, let's go back to 8.1 notes, which was the Pythagorean theorem stuff. And I need you to tell me if we finished. I feel like your class, we may not have done the trapezoid problem on the second page. I think I said to you guys, remind me we haven't done that. No, we did, maybe, I think. Did we do all of that? Awesome. We did everything. Some other classes we didn't. So I don't know. Probably because you guys don't talk to me. Maybe that makes it faster. It may have been that we were in person for these, whereas I was virtual with some of the other classes because it takes longer when I'm asking questions and there's the delay and then I have to make you guys talk to me and whatever. So usually in person it's a little quicker. Okay, good. All right then. Is there anything that you would like, general questions you want me to go over, review? So let's just I'll remind you of what's on this test. You're going to have 7.4 is the geometric mean stuff. So that's these equations, but it's also the square root of the numbers. Okay, so it's the problems where you have to set up the proportions and solve, and it's also the ones where I say, what's the geometric mean of these two numbers? And then 7.5 is what we just did, which is side splitter theorem. And the when you have a triangle with an angle bisector, how it cuts these segments proportionally. Oops. How that ratio is the same as that ratio. The side splitter theorem is the one that you've got the triangle and a parallel to one of the sides. And it says that this is to that as this is to that. Okay. 8.1 is Pythagorean theorem and Pythagorean triples. Now, on a Pythagorean theorem problem, if I say I want an answer exact and simplified, let's say you do the Pythagorean theorem and you're solving for like x here, and let's say this is like 10 and that's let's go 20. Okay, what would your equation be for that one? Paul? Okay, 20 squared is 400, 10 squared is 100, x squared plus that. So if you get x squared equals 300, what kind of answer am I looking for if I say exact and simplified? How would you express that answer? You got square root of 300. How do you express that answer? Jeff? As a radical. So if it's a word problem, maybe I'd have you round it. Okay, but that'll be square root of 100, square root of 3. Okay, so 10 root of 3. If it's a word problem and I say round to the nearest whatever, you can just type it into your calculator like square root of 300. You don't have to do the simplifying first. You can, but you don't need to waste your time simplifying if you're going to round it off. If I don't tell you what to round to, that means that it should be a radical or a fraction. You shouldn't be doing any rounding or decimals that are exact. Okay, so 8.1 is Pythagorean theorem, Pythagorean triples, and then 8.2 is 30, 60, 90, and 45, 45, 90. Special right triangles. And then 8.3 is our SOHCAHTOA stuff. So you need to make sure that you know, like on these, for example, you need to make sure that you know the ratios, because I won't be giving you those. You need to make sure that you know on a 30, 60, 90, what is the ratio of the sides? And same thing on a 45, 45, 90. So on a 45, 45, 90, you got a 1, 1, and root 2. And then on a 30, 60, 90, you got a 1, 2, or root 3. How do you know, because this is also something that happens, how do you know that when you got the 1, the root 3, and the 2, how do you know that the 2 is on the hypotenuse and the root 3 is on the legs, on the long leg? Because sometimes we've got 1, root 3, and 2, but we put them in the wrong spots. How do you know that the hypotenuse should be the 2? Jake? Yes, root 3 is smaller than 2. Right, this is 2 is the square root of 4. So square root of 3 is smaller, which means it cannot be the hypotenuse. Okay, so just kind of do things like that to help you remember how it's going to go. And also the one that has the 30 in it, that's got the 3, is the one that has the square root of 3. Okay, the ones that have congruent angles, because these are, because these are the same. It has 2 congruent angles. It's got the square root of 2. It's got 2 congruent sides, so it's got the square root of 2. Okay, this one has 3 different angles, so it has 3 different side lengths, and it's got the square root of 3 in it. So just have ways to help yourself remember so that if you think you know it and then you're on the test, you're like, oh shoot, I can't remember, which one's which. Is that a root 2 or a root 3? You can figure it out. Okay, the other thing you could do is you could solve 1 squared plus 1 squared equals x squared. That's 2. That means that x is square root of 2. So if you forgot whether that's a root 2 or a root 3, you could also just do the Pythagorean theorem. Now, you don't want to have to do that because that's going to eat up time. You're going to have to watch the time on this because this is one of those, this material with the right triangles is one of those things that some people will like get it good done, and others of you are going to get stuck on things like you do an entire section using trig and then you realize, wait, that was supposed to be special right triangles. You have to go back and redo things. Just be really careful that you're looking for, are they special right triangles before you worry about doing any trig. If I say exact, that means don't use trig. Okay, exact, unless it's one where I gave you radicals like this instead of what's the tangent of 30 degrees from the picture or something. Okay, but if I say exact, I'm not looking for trig. That's kind of a general rule of thumb. Okay, and then again, make sure you know the SOHCAHTOA shortcut. All right, there could always be, when you're solving, especially the geometric mean, these proportions, remember there could be factoring or quadratic formula. Sometimes you get quadratic formula problems on those. So if you don't know the quadratic formula, that's something that should be in your toolbox. I'm going to play you a song. My class yesterday loved that so much. Okay, so there could be factoring, there could be quadratic formula in there. If you want to take a picture of that, go ahead. And I'm going to bring up a video. So maybe we'll leave that up. So the review for the test, I gave you sample problems, but it doesn't mean that I gave you something for every single topic, because there's a lot of things that I could ask you in those chapters. So just make sure that, you kind of have a good overall understanding of everything, so you're not just looking at the problems in the review.
Square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Quadratic formula of negative
Sorry,
b plus or minus the square root of b squared minus 4ac